Hello everyone, welcome all of you on OER on concept of mean term and max term in digital electronics, specifically for simplification purpose of Boolean functions. This work is a part of a STTP on ICT in education for online and blended learning organized by IIT Bombay. A learning objective for this small OER is the learner will appreciate significance of simplification of a Boolean function, will also able to explain concept of mean term and max term, will also able to explain the concept of adjacent cells, and finally familiarize with the K-map, which will ultimately used for simplification of the Boolean function in next presentation. Simplification of a Boolean function is required because smaller number of gates reduces the cost of implementation. So we learn various techniques to Boolean function little later, and for that mean term, max term, K-map and literals, these are the important terminology one has to appreciate. K-map consists of several cells. Say for example n variable, it has 2 raised to n cells. So these are cells. A very simple example of a 2 variable K-map is shown here, whereby the cell value is nothing but the output value. It could be 0 or 1, being a digital variable. So if it is this particular cell is 1, that means for 0, 0 combination it should be 1. Mean term of n variable can be looked at the combination of various literal. Literal is nothing but a variable which is specified either by 0 or 1, specifically a dash or a, if I take a as a variable. Mean term of n variable is represented by product of literals, and a rule is that it appears only once, exactly as once. So for example, this 4 variable ABCD, which represents mean term number 13, can be written like this: ABC dash D. Now A and B easily can be replaced as 1, 1, and C dash as 0, and D is 1. So this is 13 is nothing but a binary equivalent number of this. Similarly, max term is complement of mean term. It just opposite to the mean term. Max term is sum of n literals, and they are also appearing exactly once, and it has a value 0 for exactly 1 combination of the value, in contrast to the earlier mean term, which has a 1 for 1 combination. Say for M, capital M, which is represented max term, which is representing max term. So M13 can be represented as A dash plus B dash plus C plus D, because these all literals are related with the sum of the literals. So this being a complement of earlier term, the same 13 number can be represented as 0, 0, 1, 0, which is nothing but complement of decimal number 13. Adjacent mean terms we mean by mean terms which are identical except for one variable. So in K-map, when we arrange various mean term locations, we make sure that adjacent mean terms are just vary by 1 bit or 1 variable change. In K-map, the corresponding cells are said to be adjacent cell if they have just a 1 variable difference. So, say for example, for 2 variable map which we have learned earlier, so this one, so this cell has adjacent cell this and this, which is just varying 1 variable. Here B is varying and here A is varying. So the K-map, which is corresponds to corresponding cell in the top and bottom rows, are adjacent also. So this is important from top row and bottom row, specifically for 3 variable and 4 variable. This is important. This is example truth table whereby A, B, C, D are input variable, F are output, F is output variable, and as we know, if I have a 4 variable, it has 2s to n combinations from 0, 0, 0, 0 to 1, 1, 1, 1. So here only 6 is shown, and this F is given as follows. So for one particular combination, whether output is 1 or 0, that has been listed. So this is called a truth table. This is widely used to express Boolean functions. Thank you very much for watching this.